So in this video we're going to continue our discussion on geometry, but we're going to specifically talk about quadrilaterals and circles. So quadrilaterals, what is it? Well, quadrilateral is simply a shape with four sides, nothing hard about it. However, there are different types of quadrilateral. The first type that we're going to talk about is parallelogram. Parallelogram is basically a quadrilateral, a four-sided shape that has opposite sides that are parallel. Very basic. We've seen this type of shape before. Not only are there parallelograms, but there's also what we call rhombuses. A rhombus is a parallelogram where all four sides are equal. And then the most common parallelograms that we know are called squares, all four sides are the same, and rectangles. These are some that we know very easily. Now, we should know by this time, because I told you, you better know how to find perimeter by this time of your life.
And all sides. And all sides.
But we need to find the area of a parallelogram. It does not matter what type of parallelogram it is, if it's a rhombus, a square, or a rectangle. The equation that we always use to find area is A is equal to base times height. It never changes. We always use this equation for area of a parallelogram. Now, let's say I have this shape. We know that this shape is a parallelogram. And our job is to find the area of it. Well, I need to find base times height. Well, I've told you before, if we see that symbol with a 90 degree on it, we shouldn't automatically know that that is our height. So we're going to take the 3.5 and we're going to multiply that by our base. And in this case, the height is standing on top of the 5. So we're going to say 3.5 times 5, and we get that our area is 17.5 centimeters squared. Right? Very simple. And we should also be able to do the same concept with no matter what type of parallelogram it is, such as a square. If we know this to be 4 inches, and this side is 4 inches, well, base times height is 4 times 4. I get 16 inches squared. That's all we do to find the area of a parallelogram, no matter whatever type it is. We just simply multiply. However, the next type of quadrilateral that I really want to spend more time on is what's called a trapezoid. A trapezoid comes in different types of shapes, as you can see up on the board. But the one thing is that they all have in common is this. A trapezoid has only 2 parallel sides. And these parallel sides are what we call the bases. Alright, so no matter what shape or what it looks like, a trapezoid will always have only 2 parallel sides. The other remaining sides can be going whatever direction they want. As long as 2 sides are parallel, you've got a trapezoid. So, in order to find the area of a trapezoid, we use this equation. A is equal to 1/2 base 1 plus base 2 times height. Alright, so what are my bases? Well, my bases are the sides that are parallel. So let's draw a picture. I have a trapezoid. And it's going to be, we'll say this is 12 inches, we're going to say this is 8, and we are going to say that this is 4 inches here. So here's my trapezoid. How do I know it to be a trapezoid? Well, first off, I have 2 sides that are parallel, this one and this one. Are these sides parallel? No, they are not. Well, knowing this, I know that my parallel sides are going to be my base, so I can plug that into my equation. So I'm going to plug that in. Does it matter which ones it is? No, it doesn't. We're just going to say 8 and 12. All right. Now, my height. Well, I've told you before, if you see the 90, you know that's going to be your height. So, that's going to be 4. We can work this all the way out. 1/2 times 8 plus 12. Well, this gives me 20. Multiply that by 1/2 and you get 10. You take the 10, you multiply it by the 4, and now you get the area is equal to 40 and 40 watt. We know our measurement's in inches, so it's 40 inches square. Now, let's give another one just so you can see it. So we'll put our equation back together where it was, and we'll give you a different shape. So our equation, again, is 1/2 base 1 plus base 2 times height. So our sides are going to end up being 6.3 centimeters. This is going to be 5.2 centimeters, and we're going to say that this is 8.6 centimeters. So what we're going to do is we're going to solve for area, and we're going to round our final answer to the 10th. All right, so first off, we need to identify what's what. Well, our bases are always going to be parallel. So when our bases are parallel, we know that this is 5.2, this is 8.6. So we're going to add those two together according to our equation. So 5.2 plus 8.6 gives me 13.8. Well, what's left? Well, that's the 6.3. We know this is also our height because we have our 90-degree symbol here. So we can put this as 6.3. Well, now we got everything we need to know. So we can say 1/2 times 13.8 times 6.3, and we get that our area is 43.47. Now, I told you that I wanted this rounded to the nearest 10th, so we're going to round that 4. That 7 tells that 4 to go up. So our final answer is 43.5. What's my units? Centimeters. Now since this is an area, it's going to be centimeters square. Alright, so let's do some word problems. The one that you read before you says, find the area of the square whose diagonal is 24.0 centimeters. Alright, so let's go back to class. Now, I went on and took the time to draw this picture out. So we have a square here, and the diagonal is basically going from one corner to the other. So we know that it's 24.0 centimeters. However, we don't know anything else about this square. Alright, so our job is to find the area of the square. Well, how are we going to go about doing that? Well, first off, you need to ask yourself, what's the degree of an angle in a square? 90 degrees. Alright, cool. This shape that I'm showing you right now, it's a triangle. More specifically, it's a right triangle. Okay? So, what does that mean? It means that I can probably find my two missing sides. How? I don't know. Maybe Pythagorean theorem? A squared plus B squared equals C squared. Well, we know that this is going to be our C. We know this is going to be our A and this is going to be our A. But here's the thing. These two are different. Are they? No, they're not. Actually, A and B in this particular problem are the same thing. Why? Because it's a square. All sides are equal. So we can actually rewrite this problem to say something like this. A squared plus A squared equals C squared. Or 2A squared equals C squared. So we just rewrote Pythagorean theorem to fit a square. We can find out what A is by knowing what C is. So let's rewrite this so we can use it. So we said 2A squared equals C squared. Well, I need to find out what A is, so I'm going to plug in 24. 2A squared is equal to 24 squared. Well, when I do this, I'm going to find out that 24 squared, excuse me, is equal to 576. So 2A squared is equal to 576. I'm going to divide by 2 on both sides, and we get 288. I'm going to find the square root, and we get a weird looking number. We get something that A is equal to 16.97 blah 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 blah. Generally, my rule of thumb is I never like to round anything until the very end, so I'm not going to round right now. It's in my calculator. I got that weird number in my calculator, and so should you. 16.970562 blah 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 blah, right? What did we just discover? We found out that A is this number, 16.97. But since this is a square, it means that all sides are 16.97. And since we're trying to find the area of it, we could basically square it, and you're going to see. So square it, guess what happens? You got A, as in big A, is equal to 288. What? What just happened? Well, a while ago, we told you that square, to find a square, you do base times height. Well, what was my base? 16.97, blah, 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 blah. What was my height? 16.97, blah, 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 blah. And when I multiply those two, and since I'm doing the same thing, it's really, I'm squaring it, I just happen to get 288. Isn't that interesting? We didn't even really have to do that step if we wanted to. So ultimately, the area for this is 288 centimeters square. So this next problem, it reads, a walkway 3.0 meters wide is constructed along the outside edge of a square courtyard. If the perimeter of the courtyard is 320 meters, what is the perimeter of the square formed by the outer edge of the walkway? All right, so before we go to the classroom, I want you to read through this problem again, and I want you to see if you can draw yourself a picture that will help you understand what's happening in this problem. So pause the video, reread it a couple of times, take a chill pill, and see if you can draw a picture. And then when you're ready, press play. So in this problem, we have a courtyard, and it's not just any courtyard, it's a perfect square courtyard. So I drew a little courtyard here. So here's my courtyard, here's my little trees and bushes and everything like that. So I have a courtyard, okay? It's my perfect square courtyard. Now, according to my question, the courtyard has a perimeter of 320 meters. Okay, if it's a square courtyard and the perimeter is 320, I would like to know how long each side of the courtyard is. Well, in this particular case, all you have to do is say 320 and divide it by 4. And you find out that one side of the courtyard is just 80 meters. Okay, so each side is worth 80 meters. But that's not all we need to figure out here. It then tells us that we want to make basically a sidewalk that goes around the courtyard. So I got like a little sidewalk that goes around it. And the sidewalk has to be 3 meters wide. So think of it from this standpoint. You have 3 meters. So here's my courtyard, 80 meters here. And from here, this piece right here, from here to here, I'm going to draw a line. This right here is an additional 3 meters. But I have going it all the way around. So if it's 3 meters on this side, it's also 3 meters here. What is that telling me? It means that from this outer part of my sidewalk to this outer corner of my sidewalk, that whole distance is actually 86 meters. How do we get that? All right, you know the courtyard is 80 meters, but you have to have 3 meters of sidewalk on each side. So if I got 3 on one side and 3 on the other, that means from one end of the sidewalk to the other side, it's a total of 86. That means that this entire new square, the outer square that I created, is 86. Well, if it's 86 on all sides, and I am trying to find the perimeter, I'm simply going to say 86 times 4, and I get a new area of 344, new perimeter of 344 meters. All right, the next thing that I want to cover is about circles. And we're going to spend the remainder of this video discussing circles and their property. What I'm about to talk about now should be probably reviewed from grade school or middle school. So it shouldn't be that hard right at this moment in time. So let's just go with the actual mathematical definition of a circle. A circle is a round figure whose boundary consists of points equal distance from the fixed point. Okay, a circle is round. Okay, it's perfect. It's a perfect circle. We understand that. That's really about as far as I want to go into that. However, there's some terms that we want to talk about. The term center. Okay, the center is the center of the circle. Well, my mind's blown. I don't know how about yours. Okay, that's pretty impressive. The center is the center of the circle. All right, now radius. It is the distance from the center of the circle to the boundary of the circle. So it's basically from here to here. That's my radius, whatever that distance is. The next one is diameter. A diameter is going from one point on the circle through the center to another point on the other side of the circle. That's called my diameter. Okay? So, radius, the distance from the center to the boundary of a circle, and diameter, the distance between 2 points on a circle through the center. Well, this means that we can kind of create an equation. We can say that the diameter is equal to 2 times the radius. So, for instance, if my radius happens to be, say, 5 inches, what's my diameter? Well, basically all I got to do is multiply it by 2, and I find out that the diameter of my circle is 10 inches. All right, let's reverse the process. Let's say that I have a diameter of 26.2 centimeters. What's my radius? Well, I simply divide by 2, and I get 13.1 centimeters. Okay? That's how radius and diameter are interconnected. All right? The next thing that I want to talk about is circumference. So let's put this information back up here. So we have our diameter, our radius, and now let's talk about our circumference. The circumference says this: it's the boundary or perimeter of a circle. It's calculated by a couple of equations. So basically think of it this way. We know what a radius is, there's our diameter. The circumference is going all the way around the circle. All right, and we can calculate it with different types of equations. We got two main ones. We have circumference is equal to pi times d. We'll talk about pi in just a second. And the other one is circumference is equal to 2 pi r. Now, pi is what we call an irrational number. We won't go into details about what irrational numbers are. However, in this class, you need to be very careful. There's sometimes, depends on what I tell you to use pi. Most of us know pi to be 3.14. Well, that's not entirely true. 3.14 is a rounded version of pi. So sometimes pi could be 3.1416 or 3.141592, something like that. And you can see the point where it gets a little confusing. So if in a math problem, if I tell you to use the pi key on your calculator, use the pi key on your calculator. If I tell you use 3.14, use 3.14. All right, so let's just go ahead and calculate a quick one real fast. If I told you that we have a radius of, we'll keep it simple, 3 inches. I want to find the diameter. Well, that's going to become 6 inches. Now I need to find the circumference. Well, it's going to be C is equal to pi times 6. And we can use the handy dandy calculator. This time I want to use the pi key. So we're going to say 6 times pi. We get that it is equal to 18.849 and a bunch more numbers. I'm going to round it to the nearest tenth. And I get that it's equal to 18.8. And what's my units? Inches. Now, your instincts, I've seen this happen, is that you might want to put inches square for your unit on a circumference. Don't do that. Circumference is a distance. It is not area. Speaking of area, let's go ahead and talk about it. Area of a circle is this equation. Pi r squared. Basically, we're going to take pi and multiply it by the radius twice. So let's use some different numbers. So we're going to say that the diameter is 10 inches. Well, my equation needs radius. So if my diameter is 10, my radius has to be 5. Knowing that, I can plug this all in my calculator. I can say pi times 5 squared, or I could say 25 times pi, because 5 squared is 25. When I do that, I get that my area is equal to 78, and we're going to go ahead and round to the nearest tenth right now, 78.5. All right, what unit was I working in? I was working in inches. So, and since I'm finding area, the unit will always be square. So my final answer in finding area is 78.5 square. All right, in your notes, I'm not going to do any more of these on video for the sake of time, because I feel like, again, this should be review at this point. In your notes, you should have a couple problems. Try those on your own, and if you're struggling, I'll help you out. Okay, so get a hold of me if you need to. The next thing we want to talk about circles are what we call tangents, secants, and chords. These concepts are almost the foundation of trigonometry, so you need to pay very careful attention to this topic because it's going to haunt you for a little while. So let's start off with a real simple one, tangent. A tangent line states this: a line that touches but does not pass through a circle at one point. So what am I saying? Please forgive me, this is not going to be a straight line, but it'll be okay. A tangent goes through and touches the circle. And that's really all it does. And it touches just at one point. I've made a tangent line. Okay, but here's the important part. Read it. It says a tangent line is perpendicular to the radius. So no matter where your tangent line is, if the tangent line was up here or on the other side, it will always be perpendicular to your radius. So my radius goes from my center down to the point at which my tangent line meets, and this is going to be 90 degrees. This is a cornerstone to a lot of the things that you'll be doing. Remember that a tangent line is always perpendicular to the radius. All right. The next thing that we're going to talk about is what's called a secant. All right. So we have a tangent line. I'm going to leave this here. We know this to be our tangent. A secant says a line that passes through 2 points of the circle. So whereas this only went through 1 point and it just touched the circle, a secant actually goes through the circle and it cuts through 2 points. That's a secant. The next one is what we call a chord. It's a line segment having its endpoints on the circle. In other words, let's think of it like this. We'll do it like this. Sorry, pause. A chord, a type of chord, is the diameter. So it's going from one side to the other. This is a chord because it's going from one point to the other. But not only is the diameter a chord, we could say this type is a chord. You see how this line segment goes from one side of the circle to the other side, but it never leaves? That's the difference between a secant, which cuts all the way through, and a chord, which is a line segment. So what I'm going to do is I'm going to actually put a real problem up in just a second, and we're going to see how all this stuff works together. You have this same problem I've got up on the board in your notes. And it reads, in the given figure, AB is the diameter, TB is the tangent line at B, and angle ABC is 61 degrees. Your job is to find angle CBT. So let's take a look at what our picture shows us. It says that AB is the diameter, so here's my diameter. Now remember, just diameter is a type of chord, all right? TB is the tangent, so this line down here is my tangent. It only crosses here. All right. Then it tells me that ABC is 61 degrees. So we'll just go ahead and write this down in our stuff. All right. So our job is to find CBT. Now remember, a tangent is perpendicular to the radius. Okay. We also know that radius is half the diameter. So what is that telling us? If we look at this line, AB, this is my diameter, but my radius is OB. Wait a minute, that's telling me something. It's telling me that this line and this tangent is 90 degrees. So from here to here, we have 90 degrees. Knowing this, we can say, hey, wait a minute, angle ABC, which is 61 degrees, is complementary to CBT, and so we can simply say 90 minus 61, and we can subtract. Well, this becomes 8, this becomes 10, we get 9, we get 2, so we know that angle CBT is actually equal to 29 degrees. The last thing we want to talk about in this video is what's called inscribed angles and intercepted arcs. All right, this is probably a very, very simple topic. It won't take you very long. Even if you've never seen this before, it will not take you long to understand. All right, so let's go ahead and read the definitions, and then we're going to explain it in layman's terms. All right, inscribed angle. An angle placed inside a circle with its vertex on the circle and whose sides contains chords of the circle. I don't know about you, but my brain just had an aneurysm reading that. Okay? What? Okay. Here is an angle. It's on the circle. You see my B is on the vertex. It means that the vertex is on the circle boundary. It's on the circumference. And then the angle goes out. Okay? That's really all an inscribed angle is. The vertex is on the circle circumference, and each side of that angle basically represent a chord. Okay? So, let's read the next part. Intercepted arc. Arc of a circle within an inscribed angle. Okay, what? Not too bad. You see this guy right here? From this point, we go around this part of the circumference in here. This is what we call an arc. Okay? It's part of a circle circumference. It's only a piece. So, this is what we have as an arc. So, where this is my inscribed angle, this is my intercepted arc, where it's just the arc. Now here's the cool part. It says this: the measure of an inscribed angle is 1/2 the intercepted arc. What? Alright, so let's just do this really simple, and this should explain it. I have angle ABC. And we're going to say that, for the sake of argument, that's worth, say, 35 degrees. So from here to here, it's 35 degrees. My question that I'm going to have is how many degrees is arc AB? And the way we write AB is like with B and a little curve over top of it. And so what we're trying to do is find out how many degrees is it from here to here based upon that arc. Now, you would think, hey, it's 35 degrees, but no, you would be wrong because this is a curve and we're not looking at that straight. Really, all you have to do to find out what this AC is worth, excuse me, I wrote B up here, it's AC. To find out what AC is worth is multiply this by 2. And you would find out that arc AC is worth 70 degrees. All right, one more. All right, so we have this shape. And I'm going to put, just to confuse you, I'm going to put another line here. So I have 3 chords, and I'm going to call this one E, this will be D, and this will be F. All right? This is what I know. I know that angle DEF is equal to 53 degrees. My question to you is, arc DF is equal to what? Well, simply, what do? You multiply by 2. So if this is 53 from here to here, that means that this arc DF, I didn't ask for side DF, is worth 106 degrees. That's it for this video. I'm not going to cover anything else at this moment in time. However, these concepts dealing with arcs and chords and segments, if you cannot get this down pat now, you will be struggling later on. So make sure you get this fundamental, because when we get into the real trigonometry, this stuff is going to really come back and haunt you. And as always, you know where to find me. Come talk to me, and I will see you in the next video.